half-day training session. Okay, so without further ado, we will start. Okay, so today's training, okay, is we'll be concentrating on electrical safety. Okay, specifically electrical safety is not the common health and safety training. This is specifically for electrical. Okay, so before we start, just some domestic arrangement over here. Your way out and Alright, first is fire alarm test and assembly point. So if you know how we came, okay, our assembly point is right in front of the building. And our exit, we can't use the lift when there is fire, so we have to use the staircase. So you know where is the staircase, fire exit staircase. Okay. Washroom location is over here. Alright, so it's the exit, and then you come to the lift lobby, and then you turn right. And most importantly now, so we are in the formal training. So it would be great if you could put your phone in silent mode. You are free to pick up your call, no problem at all. Okay, yeah. This is an adult training session, so you're free to take up any call. You can excuse yourself and then take your call outside the meeting room, and then you can come back in. Okay, and then be aware of the hazards around the room. Any tripping hazards. Okay, this room is a little bit cramped, so while you're moving in and out, just be aware of it. Okay, lunch and tea break arrangement. Okay, we have the training is up till about 1:30 p.m. Okay, so so we have a short tea break time, about 10:30 around there. Okay. Okay. Right. Next is I'm talking about myself. A little bit about myself before we move on to the icebreaker. Okay. So my name is Sethu Ponniah, my full name, and you see my education. I have done my master's in Master of Science in Renewable Energy Engineering in Scotland. Okay. So it's Harriet-Watt University. And then my first degree is in electronics and control system in Liverpool. Okay, so truly a Liverpool fan. Okay, all right. And then my work experience in this industry is 23 years in electrical engineering industry, and out of the 23 years, about 11 plus years at ABB. Okay, why I stress ABB over here is that despite having the remaining years, this 11 plus years is the one that I had my professional experience. Okay, my professional experience in my work. Okay, exposure to standards. Okay, so this is how I grew professionally. So that's why I'm highlighting this 11 plus years at the ABB. And out of 11 plus years, 7 years, I was appointed as the ABB, as our country electrical champion. So, if not because of ABB, I don't think so I'll be standing here and giving out this presentation, okay, on electrical safety. Okay, so my specialization in while I was there, this was electrical protection system. Okay, where I got my formal training at ABB in Finland. Okay. All right. So I have introduced myself. Now, before that, okay. So let's briefly introduce yourself, your name, and where do you work, and maybe something that what is your hobby? Just a short one. Okay. So shall we start?
Okay, I'm Evelyn from Maths Training and Consultancy. I'm being the director, so and assisting my husband currently. Came together to join this as well.
All right. Okay.
My name is Bala. I'm a freelance electrical, servicing and wiring works and so on. So together with Sethu, so we do a freelance for some shutdown or servicing power stations and so on. So that's my work mostly.
Michael, I'm a regional HSC for DHL, so I'm in the regional APAC role. So I started this match training and consultancy because I want to work with my friends. We want to do some trainings and then to support the communities. So that is, I have few partners works with me. So this is how training and consultancy started. So I'm passionate on my trainings and I do a lot of consultancy on ISO management systems, other business development systems. So that is my passionate now. So that's what I started. So I think that's short about me.
Okay, thank you.
Okay, my name is Bala. Okay, I attached to United Integration Technology, where we sell test and measuring equipment. Not only sell, we also manufacture test and measuring equipment. So I'm this line about 30 years. 2025, 30 years in test and measuring instruments. Right.
So real professional.
The times run very fast. So 30 years.
Yeah. Okay.
Yeah, time runs very fast.
Yeah, I'm Selvaraj. I'm from, yes, of course, I'm also from United Integration Technology, but I manage another company called RAM Solutions in Rahat, where we are an electrical contractor, and our forte is actually renewable energy. We do solar installations, and we are, I would say, a certified installer in Malaysia. We do EPCC projects. We do quite a number of solar projects in Malaysia. That's what we do.
Okay, great. So all of us have some, most of us have the experience in electrical works here. Okay, all right, great. Okay, so next what we'll be doing is just an icebreaker. Okay, I would like you to name 7 countries that ends with the letter Y. I think a lot of us most of us like to travel around, right? Okay, so I'll give you about 2-3 minutes. Okay, and then you can discuss among yourselves. So now you know each other well. Okay, discuss. Okay, 2-3 minutes and come up with 7 countries that ends with the letter Y. Okay.
Germany.
Germany, Italy,
Okay.
Norway.
Norway.
Okay, you can write up here as well if you want to. Feel free to move around.
Okay, so let's write. Italy, Germany, Norway, right?
Norway, yeah.
Okay. Huh?
Anyone? Contribute to Michael to write it down?
Repeats? No. Okay.
Wow, it looks like so easy.
So there are 7. Actually, there are 7.
7 countries.
7 countries.
Oh, exactly
One
7 now.
Exactly 7.
Then you can go to Google.
Oh, no.
Is there any option?
Oh, no option.
Okay.
Yes?
Paraguay, Uruguay.
Yeah, para.
Uruguay, yes.
Okay, 2 more to go.
2, 3, 4, 5. Argentina, Brazil, South and South Africa, Venezuela.
Think about somewhere between Asia and Europe. Asia and Europe.
Turkey.
Turkey.
That's the two, Asia and Europe.
Turkey.
1 more to go. Asia, Europe, America. There's nothing in Middle East.
New Zealand,
Nothing in Middle East.
Middle East, UAE,
No, there's nothing in Middle East.
Qatar.
nothing.
That's like, it's in South, another one in Spain, in Poland.
Sicily. No,
Yes, do.
Okay, what?
Just one.
One more?
Yeah.
Last call?
yeah.
No. Okay, let's see. What is it?
Bulu
Hungary.
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 Yeah.
Hungary, okay. Very good. Okay.
Okay. So how many of you have gone to any of this country?
1, 2, 3,
Italy, Germany,
Turkey.
Turkey.
Turkey. Anyone has gone to any of this?
None of
Germany.
it.
Germany. Anyone gone to South America?
No.
No. Okay. Okay. So that's good. So that was a good icebreaker. So we move on to something closer to our subject. Okay. Another icebreaker is that, okay, if you can share one incident, okay, each one of you, where you came in with a malfunction equipment that you've been using of recent. Okay, can you share one incident? Maybe you were changing the bulb, maybe the bulb blew off, or you were having something, your iPad or iPhone, and then it just burst while charging or something like that. Anyone? So far, no. Go back.
Mainly the bulb, yes.
Ah.
I was trying to change. Those days in the 90s is the normal bulb, the
The
100
incandescent.
watts.
Ah,
So
incandescent
I'm trying to install, suddenly it burst.
Okay, so how were you on it burst and then did it burn your
No,
anything?
because I was holding the bulb. No, the image was there, it's broken.
Okay, no,
The small, the glass piece.
Okay. Alright, so you didn't get any injury? Nothing. Okay, that's good. That's
Thank God.
thank God. Okay, anyone else?
I have one incident.
That's a
Oh,
big incident.
Water heater, my house water heater, there's a sound, malfunction sound. So I tapped it, electric shorted, I went back, hit shower screen,
Okay.
and the shower screen broke,
Uh-huh.
and then there's I have a cut.
Oh. So you have to go to emergency?
Yeah, we went to the nearest clinic first.
Uh-huh.
They just put some bandages and all that.
Wow.
Then following me on medications. All over his body, because all the broken pieces get on his body all over.
That's serious.
Since then, I won't ask him to repair anything.
Did it trip your house?
He didn't see right.
Didn't, yeah.
So we'll be discussing about that shortly. Okay, but you don't sleep, you sleep and fall down, I mean, because of water or anything?
No, that.
No, just due to the electric short, yeah.
It
He
pushed.
tried to avoid himself and then he fell on the shower screen.
Okay.
Hitting that for shower screen.
Yeah.
Oh, that's serious. It's really serious actually.
Lucky, actually.
Yeah.
Right.
And no one else know actually. He called me and said I was at downstairs. Only when he called me, know something happened in the master bedroom. Then only I rushed to the room.
Okay.
If he fainted or what, nobody knows actually. Yeah,
Hey.
something.
So we'll talk about this incident later on. We'll take a case study on that. Okay. So anything, Baba?
Not
In
really.
this freelance period that you've been working?
Sometimes, we accidentally wire it wrongly, then I get ourselves into trouble,
Okay.
Human errors.
Okay.
The equipment failures are very seldom.
Okay. Okay. Got one point, something to do with our topic later on. Okay. All right. Good. So, okay, the course objective here, we have 3 objectives. Okay. This course is actually supposed to be about 1.5 to 2 days full training. Okay. I've shortened it, just like an introduction. Okay. And so we are only moving on into, we only be focusing on 3 things over here. Okay. First thing, okay, the pointer is not that very strong when you point to the TV. Okay, so just bear with me. Okay. Okay, first one is to understand the 3 hazards associated electricity. Okay, and this is the major thing that we'll be discussing a lot. Okay, so we are very much, most of the electricians, engineers, technicians are very well versed in other things of that depends on electrical studies. Okay, but this thing we always miss out on this thing. Okay, the hazards. Okay, we don't really talk about it. Okay, until now. Okay, so there's more attention given to this. Okay, because there's too many accidents because we don't know what this hazards. Okay, next is we will be learning to identify and apply electrical safe practices. Okay, and then the third one is learn to choose and use the correct and standard tools and PPE for the specific work application. So we have experts here, okay, regarding PPE. Okay, so we can share. Okay, it's not just I'll be talking. It's not going to be a one-way communication. All right. So feel free if you want to share your opinion, share your experience. Just put it up your hand and then we can share all together. Okay. Okay. All right. So this is the course content for today. So it looks quite comprehensive, but it's not really much. Okay. So hopefully we should be ending by 1 to 1:30 today. Okay. So we have the address program, we have done that. Okay, and then you'll be first thing you'll be talking about the 3 hazards associated with electricity. Okay, and then we'll be talking about incidents that associate with these hazards. Okay, and then after this we'll have a short break. Okay, short tea break. Okay, about 15 minutes, 20 minutes or so, and then we come back and move on to the electrical safety rules. Okay, and then identifying and applying safe approach distances. Okay, this is something SAD in short. Okay, this is something a lot of work sites, okay, we do not observe. Something that, true from my observation, unless you're from a company, you are working in a company that actually has these rules in line for you to follow. Okay, otherwise, most of the contractors that I come across, they don't really observe this SAD. Okay. And then identifying the absence of voltage, okay, before you start work. And then we'll be discussing about log out, check out, and group rotor. Okay, this we'll be also talking about earthing, okay, and short circuiting. And before that, and after that we'll be going to planning and preparation before we start work, which they call it as in short form is HIRAC. Okay, and then finally we'll go for the we'll talk about the PPE, the proper selection, usage, and care of insulated and operated. And before we end, we'll go for a Q&A session. Okay, so that should last about depending how many questions you want to ask. Okay, probably about 15-20 minutes we'll take on that. Okay. All right. Okay, this is the learning outcome. By end of today's training, you should be able to know the 3 hazards of electricity. Okay, and then how to apply risk assessment and hazard identification. Okay, and how to use the electrical safety metrics. This I'll be adopting ABB's metrics. Okay. All right. So the first one. So the first hazard is shock. Okay. How many of you remember this? Sorry. How many of you remember the 9-volt battery. As kids, what we used to do. If you are 80s kids, we all are 80s, 70s and 80s kids. Have you done anything with a 9-volt battery? This is something playful thing that we used to do.
Yeah, motor, small motors, connect it.
Other than that, it's something really silly. But I have done that.
We put in the mod.
Thumb.
Tongue.
Have you tried that?
Yeah.
As in when you were small?
Yes.
You tried? Put, you know, because the terminal, the positive and negative terminal is just side by side. Okay? So have you done that? Just put on your thumb. Never tried. Okay, you used to try that.
When we were young, our interest is different.
we couldn't find the 9-volt battery in our place. So probably.
Okay. So we didn't know what was it about as kids. Okay, and I don't know, by accident. I don't know why. I can't remember why we did that, but we tasted that, and then it was. What do you have? What do you get? Those who had experience. What you felt?
Actually, I didn't try it personally. My friends, I have seen my friends, but I
Okay.
didn't know what happened after that.
Okay, it's like a sudden shock.
Oh,
Okay, right? You feel like the taste is something, it disrupts your taste bud. Okay, and then it's like, ooh, like a quick shock. Okay? So that is a small, very minor experience of having a shock. Okay? So first thing we'll be discussing about shock. Okay, this is something that's really, really important for us to understand. Okay, how does electric shock behaves? Okay, so knowing that our human body, okay, it consists of how many percent of water? About 75% of our body is water. Okay, even the earth is about 75%. The whole earth is 75% consisting of water. Okay, so what is water in electrical terms? It's a conductor. It's not a very good conductor, but it is a conductor. Okay. Okay. So this table, okay, this table shows how many amps, what is the effect on your body. Okay, instead of this table, I always prefer to use this graph. Okay, which gives you the idea of what actually happens to your body. Okay, so when you get electrical shock, okay, at 1 milliamp, you don't feel anything. 1 milliamp is 0.001 amps. Very small. Don't feel anything. Okay? And then we come to 3 milliamps. Mild sensation. Probably that's what you felt with that 9-volt battery. Very mild sensation. Okay. And then we move on to 10, about between 3 to 10 milliamp. Okay, when you see this graph, this is not like a digital graph that you see, okay, it's 3 means 3. This is still, all these things are still analog. Okay, it's like, it fluctuates, surge and stuff, so it's not very accurate, but about there, okay, we are talking about there. Okay, at 10 milliamp, paralysis threshold of arms. Okay, so when you get shocked, okay, it all depends how you get the shock. I think if you're holding it, you might not be able to let it go. Okay, why? We'll talk about it shortly. And then magic number. Okay, why 30 milliamp is magic number? Come to it shortly. At 30 milliamp, respiratory paralysis. What is respiratory paralysis? Your breathing, something to do with your heart. Okay, it starts to stop. Okay, so that's the magic number, 30 milliamp. Remember this. Okay, then we move on to 75 million fibrillation threshold. What's the meaning of fibrillation? Anyone? Anyone? Okay, fibrillation is your heart. How does your heart pumps? It's a strong pump, like this. That's why, remember they call it locked up, okay? Fibrillation is, your heart is pumping, but it's like this, okay? It's not a strong pump. Strong pump is, it pushes out your blood out from the heart, and then goes to your system, and then it comes back in. So when it fibrillates like this, it does not actually pumping out anything, okay? Maybe little by little, okay? Okay, and then at 250 milliamps, fibrillation threshold may produce a 99% uncoordinated heart action. Okay, our body, our nervous system consists of some very small electrical conduction. Okay, so there is all of our nervous system has some electrical conduction. So when an external current, you come in contact with external current, okay, external electricity contact, okay, it will overpower your body system. Okay, so this is where 99.5%, so it's like almost 100%. Okay, the heart action stops. Okay, and your heart actually stops anywhere after the 1 end or somewhere around here, 4 ends, and then the rest is your tissue burning, your tissue starts burning. All this happens not in a 1 minute or 2 minutes, in seconds, in milliseconds, really very fast. Okay, you hardly could do anything about it. Okay. Okay. So anyone here have gone through CPR training? CPR training, Michael? Anyone else? Okay, as a person who's dealing with electrical items, everyone's supposed to go for CPR. Okay, anyone has given CPR before? Okay,
Right. Yeah.
you have given CPR. Okay, sorry?
I follow instruction of the, I think, called 999. So they
Paramedic.
Oh, okay.
So they instructed us, so we tried.
Okay, you remember the stats?
30 times. I cannot remember. I remember the 30 times after that.
Yeah, so 30 compression and 2 blows. Okay, but now the last that I attended, they say they don't even have to give any mouth-to-mouth resuscitation anymore. It's just compression, keep giving compression. And something new is that, not to say exactly new, just been, I think Malaysia has been actively doing this, is that the AED. Okay, we've been providing AED in most buildings. So whenever you go to some new buildings, okay, and you're going to spend there for some time, get to know where is your AED. A lot of shopping centers have this provided. Yeah. So, what is AED?
Automatic electrical defibrillator.
Sorry.
Automatic electrical defibrillator.
I think it's automatic emergency defibrillator. Defibrillator. So fibrillation is this. You defibrillate means you reverse it. That's what they mean by defibrillator. Okay. So that's any in the future, if you get a chance, please go and take that CPR course. It's really vital for us, especially who are in electrical jobs. Okay, really super vital, I would say. Okay. Okay, electrical shocks. So there are several factors that determine your how electrical shock acts on your body. Okay, so it's not that everyone gets electrical shock. Okay, they die. Okay, they don't. Not everyone gets electrical shock, they die, they get injured. Okay, it all depends on the situation. Okay, so it all depends on the voltage, the duration, the current part, okay, and then the resistance. You yourself have a body resistance. Okay, so right now we are in this room, same condition. Okay, everything is the ambience, everything is same, but we have, this is not accurate, but okay, so we'll get Balak, can you volunteer? Okay, so I'm going to take the body resistance, just a rough idea, okay? Touch in one hand over here, no, hold it, and the other side. Okay, so he's coming about, his body resistance reading is about 1 mega ohm. Okay, 1 mega ohm. So this is Bala Krishnan. Okay, 1 mega ohm. Alright, so next we move to, anyone from there?
Superconductor.
Oh, okay.
Another Bala.
Okay. Amazing.
0.6.
6 mega ohm.
6 mega ohm.
Wow.
6 times more than him.
Oh.
Maybe because of the cool aircon.
There's a lot of factors. He might have more water in the morning.
Mhm.
He might have less
Less
water
water.
in his body now. Okay, and then maybe his hands, okay, might be a bit rougher.
Mm-hmm.
Okay, his thickness is thicker.
Mhm.
I mean his skin thickness is thicker.
Mhm.
Okay, so and also sometimes his gender as well. Okay, so now we try and evaluate.
Oh, the tape.
Okay. Oh, she's more than you. It's about 5 mega ohm. Okay, so a lot of factors.
He's a superconductor.
It's a superconductor.
It's key.
Okay, just for a discussion purpose, you know what is superconductor? What is superconductor? If superconductor is proven, whatever that we have studied, engineering,
Mm-hmm.
is null and void. Because superconductor is, resistance is 0. So when resistance is 0, what happens? Your Ohm's law can't be used. V equals to IR. So if R is 0, everything is 0.
No, but the cable, okay, let's say if you have a cable, then the losses on the cable will be 0. If you have
Yeah.
the losses will be 0.
Losses will be 0.
I square R loss.
Correct. But what I'm talking about is all the laws, in electrical laws, everything got to do with resistance. So if that is proven 0, whatever that we are studying is null and void. We have to, the engineering have to start back all over again. But so far there's no superconductor yet. Okay, I think this is back when we were still in college, okay, university. They were talking about superconductor. It was more than 20 years ago. Okay, so this is what one of our lecturers was talking, exactly what he's saying. If that is proven, all the laws that we study in electrical will be null and void. Okay, that's just the point of interest. Okay. Okay. Okay, so as we were talking about, there's a lot of factors. Okay, so one factor we'll be talking about is how a 50 volts supply can actually kill you. Okay, so remember the magic number. This one is only 30 milliamp. Okay, so you will see this. This is just a 50 volts supply. Alright. So let's say your resistance, body resistance is 1500 ohms. Okay. Maybe when you're at site, you perspire a lot. Okay, your resistance becomes lesser and lesser. Okay. And then, if you follow the Ohm's law, V equals to IR, V is 50, R is 1005. Could you calculate? Does it come exactly to 30 milliamp? Just have a check. No? Just do a on your
V is 1,500.
R is 1,500
Okay. Times 50.
times 50.
75K.
No, 75. E is 50. Okay, so
V
50
equals to I.
divided by 1,500. 50 divided by 1,500.
Yeah.
30, right? Become 30 milliamp. So at 30 milliamp, we saw this. What happens here? Your heart starts to stop. Okay, for some people we've experienced even at 1 amp nothing happens to them. Some, you're unlucky. This is what happens. Okay. Okay, so back then people used to talk, okay, when you get electrocuted, people take the shortest route, okay, from the body. Why? Because current always flows in the least resistance. In a circuit, it will flow in the least resistance path, okay. But in actual, once it goes to the least, okay, to the least resistance, but in actual, it actually goes through your whole body. Okay, so your nervous system, your skeletal system, okay, every part. Okay, so when you get electrocuted, shock and electrocution is different. Electrocution is, and it goes on and on. Okay, so when you get electrocuted, when you get burned, okay, this is your skin layer, alright? You have your flesh layer, sorry. So your top part is your skin, and then fat, and then muscle. So remember when sometimes when you read the newspaper, you get they say they get 2nd degree burn, 3rd degree burn in an accident. This is what they mean. 1st degree burn is your skin, and skin is what in your body? Your skin is the largest organ. Okay, our body, our skin is the largest organ. So when we lose that, so imagine what happens. So hence why you see when people get hot flash burns, sometimes they, after some time, after maybe few days in the hospital, they just die. Because if their skin is not there, it's nothing to protect you. Okay? And then 2nd degree burn, and then when it comes to muscle, it's 3rd degree burn. And then also depends if it's a small area or a large part of your body. Okay, we talk about AC and DC. Okay, so what deals with a lot of DC currents? Okay, what's the difference? AC and DC circuit breaker. AC and DC circuit breaker. Can you use an AC circuit breaker in a DC supply?
I would say yes.
Okay.
But you have to do some calculation to suit for your DC application.
Okay. So why you resort to using DC circuit breaker?
Oh, if you ask me, in the early 90s, when there is early 90s or beginning of 2000, when we start dealing with solar, we don't have DC breakers.
Okay.
You can't find it in the market. So what we need to do is we buy the DC breakers to suit for DC application.
Okay. But do you think it's suitable and safe?
Maybe no.
Okay. Which is true, which is not. Yes, you can use, okay, those breakers. You can use AC breakers into DC breakers. DC breakers are very, very expensive compared to AC breakers. There is a reason why it's expensive. Okay, why? Okay, let's see. We'll come to this board. Okay. Okay. DC current. How does a DC current waveform looks like?
Straight line.
Straight line. Okay, and an AC?
Okay.
It alternates. Okay? Alright. So when you have an arc flash, an arcing, okay, what's in the breaker to extinguish the arc?
To break.
Like if it's a big circuit breaker, they call it the arc chute and all those things, right? So when you have continuous current going through your breaker, it's harder for the flash arc flash to because continuously there is arc flash. Whereas when you have AC, okay, you have zero energy level and then it goes up and comes down and goes up and comes down. So it is easier to manufacture, okay, compared to DC, right? So the real answer is if it's not advisable at all to use DC breakers. Just for your information, for future projects that you have, that you need to talk to your customers so that you can explain this way what's the reason and stuff. Okay, definitely it's cheaper AC. Okay, Malaysia always go for cheap. Okay, they call it cheap and cheerful.
But
which is
now
not
we
good.
don't use
AC breakers.
AC breakers for DC application.
Hmm.
I'm telling you, in the early 2000s, it's very difficult to find DC brake at that time.
Correct, but I frequently see in your circuit, in your circuit board area, circuit boards, okay, when you have those 2-pole MCBs, those small MCBs, a lot of contractors boleh pakai. Okay.
We don't.
So if you're doing that, it's a very good practice. Okay. 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 So that's a little bit about this AC and DC current. Okay. An energy source, potential lightning strike should also be considered as they also present a risk from induced voltage or capacitive charge on the equipment. Okay, talking about capacity charge, okay, those who are in switchboard business, how your bus bars, okay, your bus bars are huge, correct? Those are the conductors. So when you switch off your switchboard, okay, the supply, if you don't discharge it, your bus bar actually stores energy. So that's the capacitance energy. So your bus bar itself is a capacitance. And so many equipments, remember some small equipments like your router or whatever, modem or something, you say if you want to reset off, wait for 5 seconds because it has capacitor inside. So discharge that before you could reset anything. So that's capacitance source. So when you want to work on anything, water heater or anything, you have to discharge. Okay. Okay. Another thing. Anyone use this before?
Yes.
Okay. Okay. I used to use this as well, but once I joined ABB, this is one thing that you're not allowed to carry a test pen. You are not allowed to carry this as well. Highly prohibited.
What is it?
This is
Like
Non-contact voltage declared.
so it's like it looks like a pen. Okay, and this thing, the top of it, test pen is like a screwdriver. Right? This will be like this. So what they'll do, they'll try to just touch. Okay,
See the electric.
it's non-contact detector.
Okay.
Okay, so when you are in somewhere like power lines, especially power lines, okay, when you go near, it starts to light up. So you don't know exactly where it is. So it's like induced current, induced voltages. Okay. Okay. We had one incident. okay, Michael, when he was repairing the heater, okay, he didn't really get, he was not really affected by the electric shock, but he got injured because of fall cuts. So that's what we call it a secondary effects. Okay, secondary effects. When you get a shock, you pull, like when you were changing the light bulb, okay, it just gave you even the sound scare you. Okay, so those are secondary effects which you have to be careful about. Okay, so most of the times people get electric shock. It's not that when you see the death certificate, it's not because of electric shock. They say it because of trauma to the head or something like that. So that's the secondary effect. Okay. So like what I said, when you get electric shock, it's not always the electric shock that is always in front of you. That very obvious. It's other things around you. Okay, like for instance, in this photo, what do you actually see? What are the hazards that you see? Okay, this is a close-up of this. One is the space.
Narrow space.
Very narrow space. Okay. Other things? What do you see?
I think this one need to be covered, right?
Yeah, the leads. Okay, because these are sharp, pointing stuff over here. Okay. Okay, so basically that's the thing. Short, confined space, and then sharp items over here. Okay. All right. Now, what? Okay, this is a new substation. Your switchboard is in. Okay. What do you think can happen? What do you see in this photo? It's a new substation. What do you see? What can happen? Think about Malaysia.
Rain,
Sorry?
water,
Yeah.
tornado.
Okay. And then new substation, but it looks you see this?
That's leakage.
Okay, I think these were blemishes on the wall, so they just put some putty over there. They haven't painted. Your switchboard is in. Okay, those who have gone to site, oil and gas site or whatever, okay, you see how the way they actually install switchboard. They just climb up. Okay, so when they don't have access, do you think the painter can climb up here and? It should not, but in Malaysia it happens. Okay, so these are not done, and your switchboard is already in. Okay, so they could be climbing up. Okay, and then here the window. Okay, is this the correct location? Okay. Okay, this one is 110 kV line. Transformer. What do you see? What hazard do you see? Cables? This cable?
Yeah.
Okay. What else do you see? When you go to any installation,
I think there's a main hole, it's not closed.
where is that? Here, right? Okay, correct. And you? Right in your face, it's there. What do you see? Exactly, ladder. There is a reason why TNB always carries a ladder, but wooden ladder. Okay, this doesn't look wooden.
It's aluminum.
Okay, so
You're still using wooden?
yeah,
Oh.
still using wooden. Okay, ladder, and then just one last thing. You see all these things not clear. This area. Okay, they barricade this. But is that enough? Okay. Right. Okay, now arc. Okay, arc is basically the next step of, next level of shock. Okay, so have you experienced any arc situation? You saw any arc? Have you seen any arc?
DC arc.
DC arc. Oh, that must be dangerous.
Yes.
Okay, what happened?
I mean, the visual, I mean, when doing the framing, we have an expert, of course, he will show the arcing,
Okay.
the DC arcing,
Okay.
to differentiate, to show how dangerous is this.
Okay.
Yeah.
Right. So those who have not seen arc, have you seen arc before? Okay, when you go home, right? It's already at night. You know this your switches.
Yeah.
Okay. So in a dark room, you try to switch on.
Okay.
Sometimes you can see it's
Yeah,
lighting up.
Oh, okay, okay.
So that is arc. Okay. Because you are actually to your conductor, you're actually coming together.
Okay.
So that's when the arc happens. Yeah. Okay. Because your potential is waiting, and then you're joining to something. Okay. Okay. So when arc happens, let's see. It actually can go up to about 20,000 degrees Celsius. 20,000 degrees Celsius is actually, okay, your surface of the sun, okay, is measured, not to say exactly measured, is about 5,000 degrees Celsius. 5,000 degrees Celsius. So 19,000 is almost 4 times the surface, I mean the sun's surface temperature. So imagine that. Okay. 4 times. Okay. Okay, now you see this. All this happens in 1 second. Okay. Okay, now 1 cm square. 1 cm square is 1 times 1 cm by 1 cm. That's the area. Get 1.2 caloric value. Okay, and you have an arc. You got it. Okay, so your skin will burn more than 98 degrees Celsius. The arc is having about 20,000 degrees Celsius. Okay, this is less for about slightly more than 0.1 m per second. Okay, this is just a case study. Sorry, not case study. Not a case study, but this is a dummy. Okay, the effects of the arc. Okay. It's not playing. No. Okay, let's wait, we have to wait for it. Yeah. Okay, this is almost the ending of your arc flash. So observe all these things. Okay. Okay. So what you saw, you want to see again? What you saw? How did the arc happen? Not how it happened. Not about how it happened. What was happening there?
It's a flash.
Okay. And then how it developed.
Yeah. How it developed.
Sorry, not how it developed. What it developed to.
Fire.
So you just saw a small
Light.
arc coming out, and then
So fire,
Fire.
fire like then like the flash,
Okay.
things are burning, and then it's like fully smoked.
Fully smoked. So this is to a level of blast already. Okay, can you see the smoke? And then another important thing, what you saw?
Some more particles.
Particles. Okay, these are shrapnels. Shrapnels means your bus bar inside or your metal parts. Okay, it has gone to roughly about 20,000 degrees Celsius. Okay, within that 1 second. So what happens? It melts. It melts. It gives out the energy and then it flies off. Okay, those shrapnel travels roughly about 700 miles per hour. Imagine Silva likes F1. Okay, F1 drives at, travels at what speed? What, 300 miles?
Yeah.
300 miles an hour speed. So it's like just like a bullet.
So Toyota's Lamborghini.
That's that is. So it's very fast. 700 miles per hour, not kilometers per hour, miles per hour. So I think it goes more than 1,000 kilometers per hour. That's the shrapnel. That's the power of the energy that is given to the metal parts. Okay. And then when the smoke comes, okay, sometimes toxic gas, okay, you start to inhale because, like, just imagine, like, how do you feel? You felt,
Yeah.
okay? It's a natural human reflection. You start to inhale. So inhale the smoke, your lungs goes off, okay? So your lungs will be affected. This smoke, and this smoke is super toxic, really toxic. Yeah. All the toxic things in your system here. Okay, we're done with shock, we're done with arc. Now we come to the final one, blast. What you see? Okay. This is your isolator, the three-phase isolator, the fuse part. Okay, just imagine that. So, your uninsulated screwdriver. Okay, so for whatever purpose, it touches the one of the face. Okay, everybody knows when you touch face to face, super dangerous. It's more dangerous than face to earth. It's more dangerous than face to earth. Okay, I had experienced face to face as well before my ABB times because of secondary effect. Okay, I'll tell you the experience later. So when you come to contact with face and body, okay, sometimes your breaker might trip. Okay, if it doesn't, what happens? How does it extend to face? How does it extend to face? Okay, earlier, your short circuit is between face and earth. How can it extend to become face to face? Any idea? Any idea? No?
Correct me if I'm wrong. When you have normally light and earth shock, your ELCB will trip.
Correct.
But when you have face-to-face shock, your breakers will trip.
Your this overcurrent protection.
Overcurrent protection, because breaker is more overcurrent, whereas ELCB is more cage current.
Correct.
So when you face to earth, it's more cage current.
Correct. Absolutely correct. No, nothing wrong. So sometimes when it fails, okay, we have seen things have failed before. So when it fails, it's actually started off with face and earth. How does it extend to face and fit to other faces? That's my question. Any idea?
When insulation fail,
Okay,
yeah.
but installation fail, okay, one.
When you first your installation fail, you probably will have intermittent fault where you have ground fault. But if the installation will get severe and it tends to have a face-to-face shock.
Okay, correct. That's one. Another thing that we always forget, all of us forget, especially those who are doing switchboard maintenance. When we go, ever so often people use what they use? Rush. Another thing is what they use. Those people who wants to do it fast. Water is totally
Yeah.
wrong, but other one they use. Do you see them using blower?
Yeah, bro.
A lot of them use blower. You're supposed to use blower. Why? You start to get all the dust to go and circulate all in your room. So what's in the dust? In the switchboard, in the switch room, in any electrical room, mainly is metallic dust.
Yeah, it does.
So when metallic dust comes about, and then you have some close, very close, face to face, okay, there is conduction. Okay, just like arcing, you have conduction. So when you have some metallic dust, there is a path for it to. So in this case, when you have face to earth, okay, either the screwdriver, when you get the shock, it goes close to it, or once there is some arc coming up here, the metallic dust or metallic shock might have given you the path. Okay, so this why I'm sharing all this that for you to think when you go to work site. Okay, you start to think, okay, I have learned this. This is possible for it to happen, so you might have to watch out. Okay, you can't use blower. Okay, you only allowed to use vacuum. Okay, water is absolutely no. We learned water 75%. Okay, right.
But mostly even we used to it's under switched off condition. I mean, it's not operating condition.
Correct. We used that before. There was one case. What happened was they did the blowing. Okay, cleaned up. They switched on. You suppose if you use a blower, you're supposed to wait an hour plus for all the dust to settle back down. Okay, there is no movement, air movement and stuff like that, and then you're on. This person they have blow, okay, still around, on.
I've seen vacuum, but over.
They decide to blow out the dust inside the, switch gear, right?
Yeah, switch gear.
Last time I see in they will blow out.
Yeah, that is okay because that was a dead condition.
Okay.
Okay, this is like when you go maintenance. When you go for maintenance,
Uh-huh.
you have maybe half a day working period. Okay, your shutdown is only about 4 hours. You must finish within that.
Mhm.
Okay, you go in,
Mhm.
and then they clean, and then they do whatever maintenance they have to do. So clean up. Sometimes the hard to reach areas.
Yeah, this is what we always do in the sites.
Site.
Yeah, outside guys, when you go clean the
Okay.
switch gear, the water servicing, they just blow out things.
Okay, and then they switch on immediately or after some time.
But they wait, I think,
Okay. So at least they wait. Okay.
We heard about one case in Istana Budaya.
Okay.
Okay. So we went to install power outlet. So the attachment said,
Told us to be careful.
careful. Then we said we normally install this power level we many years, so we are confident lah. So say careful lah, here ada kematian no. So what happened is
He was doing maintenance, and one section of it was still time backing. So he was using brush,
Okay.
and happened to be the brush had still this conductor, right? Metallic part, and somehow
I think it created a magnetic field. So someone don't switch on. So this fella who cleaning, got press.
Oh, okay. So any injury to the
He died. He died.
Okay.
Serious.
Just because of a brush.
The metals.
The metal.
Yeah, some brushes.
Because when you use a brush, it creates the magnetic
Oh, okay.
field. So
Okay,
maybe
it was one section off, one section was still alive. And by right you should use some kind of material to cover, right, to take the life, and where do we practice all that in Malaysia?
Yeah.
So he was working and he came close to the live area, and somehow the thing jumped to the brush and
I understand what he does because I myself have experienced that situation where like what you say, where the Malaysians have take up all the precaution to do that. It's only the big companies, the ADB, Siemens, they have the strict rules for otherwise. Because before I joined ABB, I also had to do all these things. Okay, the compartment, the switchgear compartment, okay, they shut down like a cat band. Okay, your cat band, you have to change the cat band. Cat band is bottom, on top, bus bars there,
still alive.
alive. And my person in charge of work didn't tell me. Well, I was about to drill to make a hole for the base of the cat band. Then he's telling me, hey, be careful, guys. It's like, how would you feel? How would you feel? I said, oh my God. Okay. So yes. So hence why I said my professional years, I still owe to ABB. That's why I actually grew up professionally. After knowing all these things, like, oh my God. I can tell you that I was lucky to be alive to what I had experienced before as well. So all the conditions, it's all because of cost. Safety is not cheap, okay, but it's vital, okay. So now we have experience. We have known how it can happen, metallic dust and stuff. So when you go back to site work and stuff, so we're vigilant about this. Okay, educate your downline as well. Okay. Okay, so this is not a real situation. We're just doing a test simulation. What will happen to the switchboard? More like it's a test facility for type tests and stuff like that. Okay. So you could see it actually reached to 8,000 degrees Celsius. Okay. TNT. How? Remember in Fort Wayne, many years ago, there was a ship full of this TNT liquid. Many years ago, I think probably this was early 2000 something. It actually exploded. Okay, because they didn't store it properly. Okay, TNT, the characteristic of TNT. Okay, and later on you can read about it in Google. You just have to, how to ignite it, it's very easy. You just have to, TNT, shake it. Okay, so it's nothing to do with this, but just sharing something, okay? So again, yeah, 700 miles per hour, the shrapnels. Okay, talking about arc flash and blast. Okay, just to give you an idea, remember during towards the end of World War II, they dropped down the atomic bomb in Hiroshima. Okay, Hiroshima and Nagasaki. Okay, so in Hiroshima, if you even go now, I haven't been, but this is what this document said. There's one place in Hiroshima where you have a shadow near the staircase, somewhere near the staircase. Okay, this is actually when that thing happened, when the bomb was dropped. person sitting down there. Okay, he actually he was not never to be found. He just vaporized. Vaporize means it's the energy. Okay, so the same thing that happens in our electrical arc flash and blast. It's actually throwing the energy out. 20,000 degrees Celsius in the energy that goes. It vaporizes them. Human, you can just vaporize it just like that. Okay, so similarly, when you get burns due to electric arc flash, okay. Do you know when you do barbecue, your chicken, okay, when it's fresh, how does it look? It's pink, right? So when you cook, it becomes
Brown.
white. Okay, it becomes white. So all your nerve, your blood vessel, everything gets hardened. So similar to human flesh. That's why when somebody gets arc flash burns, okay, they are in the hospital for a few days and then they die. You know why? Because their flesh is already cooked. Flesh is cooked. So it's just waiting for time, no more blood flows, nothing, they just die. You know, so that's the reason you say, hey, oh, okay, he got arc flash blast, he's admitted in the hospital, hopefully it goes well, but doctors know most of the time it's just a few days. Happened in EBB itself, okay, one incident, okay, so that was a very sad incident. It was even before my time, somewhere in 2005. This service guy, technician thing. So he went to Gebing, I think BASF plant. So that was a mistake by communication mistake, I would say. Okay, so he went there. His job was to measure and cut the perspex polycarbonate, so for separation purpose. Okay, so you have incomer 1, incomer 2, your bus die area. Okay, now say incomer, one of the incomer. So the person in charge at site inform him. That means the customer side. Customer side, okay, on your bus A, bus B, one of the buses is dead, so you can do your measuring and stuff. So he went and measured. He was measuring at the wrong bus. So, and he was using a metal measuring tape. This was in 2005. Okay, so measured. And it was a very sad case because a few weeks before that, he actually requested from his manager that he wants to stop going to site. He wants to be based in office because he was expecting his firstborn. So he couldn't see his firstborn. A few days in the hospital and he just died. And ABB cancelled its annual dinner just around the corner because of that. It's a very sad case because he requested that and the manager rejected. He doesn't want to crunch for him to come back to office. No, come back means station in the office, maybe a different department. Okay, so later on the manager was a Norwegian guy. He actually became a very bad alcoholic. He couldn't forgive himself. And since then, the last it was a few years back before COVID, I heard he was still unable to forgive himself. Okay, so think before you act, because you don't want to, either if it's due to your instruction or you are the worker yourself, think a few times before you actually get into the job. Okay, remember, it's a job, it's not our life is something else. Okay, this is the way for us to earn money for a living. Okay. Okay, we looked into support. We look into incidents and then we take a break. Is it okay? Okay, it's a very quick one. Okay, we just go through some electrical incidents. As an example. Okay, now this is a real case. Okay, no act, nothing. You just observe what is happening. Then you let me know what we actually saw. Okay. Okay. What you saw? What was wrong?
He was doing switching
Okay.
and he was not wearing a vest suit.
Okay.
No proper PPE.
Okay. Anything else? Anything else you saw?
The door is open.
Exactly. Anything else? Michael, anything else? As well. One of the thing, PPE is yes, but before that, how did he even break in the breaker without the door being closed? This was another mistake because the door, if he had locked, maybe the outflash would have been not prevented. Outflash would have been reduced. It wouldn't have come. It wouldn't flash out from the glass.
When you break in, you have to open the door, right?
If it's a proper switchboard, okay, there is, especially for MV switchboard, there is interlocks. If you don't lock the door, you are not able to, there is a magnetic lock over there, okay? If the door is not locked, interlock, you are not able to put in the racking handle, you cannot put in, you cannot insert it, so there is an interlock. Similarly, for LV board, they can bypass, but if you bypass, then if something happens, then it's the switchboard company is not liable at all because you have already bypassed it. Okay. So for LV board, also they have door interlock. Sorry, if you don't lock, you cannot rack it. Okay. So I'm not sure about local panel builders, but for either ABB, Siemens, or Schneider, or anyone, they have this. Door is not locked, the door is not closed, you cannot rack it. Okay. So same as well for the cable compartment. It's also same. If it's not switched off, you cannot open it. Okay. So good observation. PPE, door not locked. Anything else you saw? There's two good things you already observed. Okay. So we'll look into what actually happened. This is the after effect. That same incident. By the way, he was alive, but what kept him alive? He actually wore the suit. Look at his visor. So in this situation, PPE saved his life. But it could have been better if he has observed the rules or the operation rules. This was actually unnecessary. I, for one, don't like to wear that outflash suit. Really, okay? It's
like a sauna.
Oh, it's terrible. Even for you to, all the gloves, it's really hard for you to feel anything and work on.
Yeah, that's why we brought that.
Ah.
I'll show you. It's very soft and it's liquid.
Yeah, okay. Okay. okay, this is the incident report. So, vertical arc flash suit was used. Speculation was wrecking breaker in life while the breaker was closed. That's the actual case. So the breaker is in closed position. Okay. So normally if it's in closed position, ABB switchgear will not allow you to be erecting. Okay, it will reject. Okay. But I don't know how somehow you managed to do this. Okay. And then no arc flash hazard analysis. Again, analysis. Because he didn't do the risk assessment. Okay, if he done the risk assessment, he would not be able to.
So the body care was sufficient?
In this case,
It was.
he was alive, so sufficient. But you all know it's. Situation will not be the same all the time. Okay, we don't know. A lot of TNB cases previously. Okay, we have seen. Okay, a lot of TNB cases are not actually published. Okay, there are actually almost every month there is a death in TNB which are not actually reported. Okay, only recently I am seeing a lot of them carrying arc flash suits. Probably the new generation are starting to wear it, but before that, in the early 2000s. There was one, we were working on this TNB, not TNB, BSN Bangi. Okay, we finished the work. Okay, TNB came. They have to, before they switch on, what they have to check. They will have to check the phase rotation. Phase rotation. So when we offered them, do you want to check phase rotation? The usual TNB arrogance. They say, you TNB or I TNB, okay? That happened, and it switched on. The next second, we're seeing that he was flying out from the substation. And the usual style of TNB, they drive their truck right in front of the entrance, and they block the entrance. Okay, so he was jumping out from the substation and landing. One landed on the bush. Another landed on his truck, and after that explosion, he came and asked us, "Can I have the?" This is too late. Okay. Okay. So customer hospitalized for 1 week period. Customer employee, sorry. So arc flash suit actually saved him. Okay. Why I want to share this as well is because no matter where in the world. Okay, people still do mistake. Germany, we all look upon Germany. Okay, standard, the follow rules, but accidents still happen. Okay, this was happened in Salzburg in Germany. This was somewhere in 2018. It was an ABB maintenance electrician. Okay, first and second degree burn to end in forearm. The employee was working alone in the transformer station, reconnecting the power supply to an emergency meter unit. He was changing the meter.
Energy meter.
Yeah, energy meter. Okay, short circuit and arc flash occurred. Okay, probably he did not switch on or off something before he connected the cable. I think, if I'm not mistaken, to the either to the breaker or something. He did not switch off. Okay. Next, this is in India. So one we saw in Germany, we saw in Malaysia, and then now we're going to India. Okay. This case is he was supposed to work in feeder. Okay. Panel which the maintenance was to be done is feeder outgoing. Okay. He went and burted the bus coupler. So imagine what happens. Now this looks like a 11 or 33 kV. This is 11 kV panel. Okay. So what? How? This is a very very bad mistake, I would say. Mistake that you're supposed to be avoiding. Okay. probably, okay, this is after the incident happened, they put this danger. But before that, was there a lotto in order? Was there a barricade saying that do not touch here? Okay. So the person was wearing outfresh suit, luckily. Okay, for cal. Okay, the injured person was given hospital and treated. Luckily, he was alive. Okay. Again, we can't predict how electricity actually behaves. Okay, this one specifically I want to share. This thing happened in this was in Turkey, I think. Turkey. This similar issue also happened in Singapore. Okay. The maintenance supposed to be in. Okay, this is the shutter. Okay, correct? Shutter. You have bus side, cable side. Okay. Normally, if you want to open the shutter, once you rack up, you can open, but it's not really easy. If it's a Tamco switchgear, very easy. If it's a ABB switchgear or Schneider switchgear, Siemens switchgear, it's not that easy for you to bring it down. Physically, you have to bring it down, then there is all these interlocks over here. Okay. Okay. So what happened is your maintenance has to be done in the bus bar side. Okay. You went and touched the cable. So could you see here? Red, yellow, blue side. Okay. Similarly, something similar, but this is in Singapore. This was by a contractor. Okay. This guy is the person who got injured is untrained young guy. Okay. He just started working. His superior, his supervisor did not tell him that he should not be touching any part, any live part, any inside the shutter. So he happily went and started cleaning, and he opened the shutter and okay. Over here, you could also do lotto. Okay, in the shutter also you can do lotto. Okay, so very few people does this. Very few people. Because electricians around the world, they always say they think that they know electricity, but they actually don't. Okay, after many years, most of the accidents is because of is by the experienced personnel. It's not the young ones. It's not the new graduates or whatever. It's the experienced ones. Okay, so the common themes. If you see, I will not go through everything. The common theme is mostly human competence supervision. So it's all about human errors. That's what I think he shared. Most of the time, the equipment does not fail. It's a human error. Okay, so the theme is human error here. Okay, so everybody looks really tired. I hope I did not bore you. Okay, so I hope you learned quite a bit over here. So you take a break about 15-20 minutes. Is that okay? So Evelyn will meet them to.
Yeah, sure.
Okay, all right. So after you come back, please fill out this form, the attendance form.
Huh? Like standing.
Feel cool.
Too long. Another one.
Phasing stick.
Phasing stick. Another one called lifeline.
Lifeline tester.
Lifeline. Okay, so voltage detector, lifeline. And then just track back now. Safe approach distance. We learned about safe approach distance. Some of the stick, okay, lifeline stick, some are telescopic, right? Correct?
Telescopic, yes.
Okay, so why is it telescopic? Have you thought about it? Try to tie up with the SAD. Try to tie up.
The distance.
Yes, the distance. Every different voltage level, you extend it
Yeah.
further. So that's the approach level. That's the reason why I said that table, each voltage level and what's the distance you could approach is quite important for you to yes, to adhere to. So that is for the first what's the first approach?
Is restricted approach.
Restricted you'll not be using because those are for unqualified personnel coming in. So for you will be limited and restricted. So that's the table that you have to use when you want to talk to your customer, saying that okay, this is important, this equipment is good because of this, and yeah. Okay, so okay. So how you use a voltage tester? How you use a voltage tester? To make sure that it's zero energy. What's the steps? There are 3 steps. Come on. Any idea? Any idea? Bala?
Switch off the supply.
How you before you start work, okay? You have your voltage tester. Before you actually test,
You're referring for LV or MV?
doesn't matter anything. Before you test, you have to check it on a known source. Known source means it's live. You know it's live. You check. Okay, it's working. Okay. Then you test the part where you want it to be zero voltage, zero energy, zero voltage. Okay. Done. And then you go back to the known energy which is live. Test again. Okay. That is to ensure that your voltage tester is in working condition. Okay.
If you doing this for the phasing stick,
But we do that only for, I mean, of course we practice this only for medium voltage testers.
Medium voltage, yeah.
So we have a probing unit.
Mhm.
So before we test it on a real system, we use the probing unit to test the voltage with the probing unit. So the probing unit probably will generate about 1.2 kV. So you read to 1.2 kV, you know the system is, I mean the device is working fine, and you test it on the real application,
Okay.
and you test it again to make sure that before you keep it in your bag, you test it again to make sure that it's still operating.
Okay,
So,
okay.
but not for LV. LV we have not done this.
Okay. LV means below 1 kV, right?
Below 1 kV.
Below 1 kV.
I mean mainly for 415 and 240. We don't practice that. But, yeah.
Yes, mostly yes, you're correct. They practice on very much they practice on medium voltage. That is true because they just want to make sure because medium voltage is the one where the capacitance on the bus bar is the highest, okay, because of their bus bar. But then again, LV is also equally dangerous. It's LV is higher current compared to MV. Compared to MV, there is higher current.
Probably one of the reason I am maybe I might be wrong because for the HV equipment you must make sure the HV equipment is working fine because you're going to put on HV and if anything goes wrong,
Yeah.
the impact or whatever the disaster can be even severe than LV.
Yeah.
So LV is so far we don't have any such thing. I mean we have not done it, but because we sell phasing sticks.
Okay.
And I've trained TNB staffs, and this is the procedure. So we use the probing unit to make sure that the system is working fine before you put on live. And then once you finish, before you put it back in your bag, you test it again before putting it in your bag. So that's what we practice now.
That's good. That's already good practice, but LV is still required because most TNB don't really much deal with the LV unless they are in the generation
The distribution.
side. Distribution and generations.
Generation distribution.
Generations when they are in their
Consumer
power
side.
plant. Okay, power plant they have a lot of LV board as well for their motors and stuff like that. So yeah.
Even consumer side, the consumer distribution and consumer,
Okay.
they use mostly LV.
Okay.
Yeah. So this one the one I'm talking about is for the substation side. The distribution is also distribution. But distribution they have two sections. One is on the LV. Yes. For domestic, where they have the PPE.
Okay.
I mean the PPU. After the PPU is LV. So the feeder pillars they use LV, but we never practice that. I mean I don't think so they practice that.
No, but it's good to be used to practice as well. Just like remember when we want to check continuity, okay? We always short it first. Our probe short it. Hey, okay, there is beep sound. Okay, then we check. Okay, then sometimes we test back. Okay, so similarly, it's good to. I know it's a longer process. A lot of people usually just ignore it for lower voltage. Yes, but it's a good practice. Okay. Okay. Yeah. So before now we're talking about the PPE again. Okay, PPE we'll talk about towards the end. So there you go. Check voltage tester for correct function on a known source. Okay. Okay, so there you go. Recheck voltage. After you test, you recheck again. Again, use only the approved voltage tester.
You were saying earlier that you don't use test pen. So basically test pen is a device where we use to know whether it's live or dead. Any reason for you to say that?
Oh yes, yes. One of the reasons is that one of the reasons is if you see your test band is only rated at maximum 400 volts. Okay. In ABB, even for LV, we have bought up till 690 volts. Okay, 690 volts. Very rare.
But that 690 is face to face, right?
690, yes, face to face, correct.
So face will be still below 400.
Yes, about that. But what they have, from the case studies, what they have come up, what they have found out that some of the step-down transformer, step-up transformer, okay, it can go, especially step-up transformer. So when they touch that, it has actually exploded.
Okay. The reason I'm asking you this question because you see in ST, Suruhan Jaya Tenaga, when you're testing, especially on medium volt, this there's a guideline to do this testing, live testing.
I'm not sure about Sabah and Sarawak. Cisco and
ST, SCP and SCSB.
So I never worked with them, but we have done a lot of projects for Shell, offshore in Sabah and Sarawak. I don't know how much they have adopted from ST.
Okay. For example, the unit that you showed earlier, the early one.
In the voltage tester?
Yeah. Okay. This doesn't show. It doesn't show exactly 0 volt. No digital indicator. It's just a range.
Correct.
Is this still acceptable?
This is to check the to identify the voltage level.
Yeah.
Okay, but the zero energy is another testing.
Yeah. Because this doesn't show 0 volts.
The point is that you don't use a multimeter. Okay, use this to ensure there is voltage or no voltage. But the zero energy is a different one. This just to ensure what voltage level is that. So you don't, as I say, you don't accidentally put into resistance value and then you test. Okay, you are exactly right. No, you are correct. 0 zero energy meter is very much required. This is to ensure what's the level of
because
it.
there are two different devices. I mean, similar device. One will give you a digital reading, and so when you put it in, it will show 0 volt if it's dead.
Yeah.
But there's another one it's just a range. It
Yes.
show you in what are the range of voltage.
Yeah, correct.
Yeah. So, but that doesn't show 0. So yeah.
So mostly that is used for site people. Those who are in the factory, no, we don't use that. So
What is this?
this is okay. This one is voltage detector.
Voltage detector.
Voltage detector. What Selva was talking about is that zero energy. So after you have checked with your voltage detector, what's the level, and then after you switch off, oh, okay, it's already there is no more voltage. But what he mentions that, remember earlier we spoke about capacitance, capacitance and capacitance energy. So zero voltage, there is another meter which ensures there is no energy left in the there's no charge left in the
Zero voltage detector.
sorry, zero.
What's the name?
It's a zero energy meter.
Zero energy meter.
Zero energy meter, right? Or something. That's another.
It's still a voltage tester. It's a voltage tester,
Okay.
but then it will show physically a
digital
digital
reading.
value
Oh,
is 0.
Okay. Okay. We use the analog ones. But now, yeah, digital.
Yeah, I mean, a lot of digital. I mean, basically, as a, it's not. It doesn't show just a range.
Yeah.
Some equipment it will only show a range. So you can be in a probably the voltage. Okay, for example, like 30, but 30 might show 0. In that range, maybe the next range probably 50. It doesn't go to 50, maybe 0.
Correct.
It shows. But if you put the one with digital indicator, it will show 30. Just give an example.
Yeah. So, sorry.
Yeah, so that's why you have to probably verify it must be 0. Right?
Correct. He's 100% correct. This is only to check what's the voltage level. So once it says no voltage, then you have to take that zero voltage meter to ensure that it's really 0. Okay, that it shows that your charge has been discharged. Okay, and no more, it's safe for you to go. You don't touch it and then you get some shock.
Probably some residual still floating inside the system.
Exactly. So it's capacitance charge.
Yeah.
Capacitance charge. So that's hence one capacitor. When you work on capacitor bank, it's really very dangerous.
Capacitor bank.
Capacitor bank. Okay. So we are very clear about how you ensure that it's safe for you to touch any live parts. Sorry, any exposed parts. Okay, before you come. Okay, so we saw the importance of this portable learning. Okay, one thing I want to ask you: when you do earthing, what is your steps? Meaning that the usual thing is when you do your earthing first. Okay, when you disconnect, earthing is last. Correct? When you apply earthing first. When you disconnect, earthing is last. So for me, what I do is that to get to this practice, even any small job that I do, even changing a 3-pin plug, I always make sure I connect the earthing first. So it becomes a habit. Okay, earthing first. Okay, something that I always also taught with my working colleagues. Earthing first, no matter what it is. Okay, even if it's a small job or small installation. Okay, it becomes a habit. Okay. Okay, this planning and preparation. Okay, planning and preparation. This is what, despite of all the things that we have studied, safe work practice, the law, the earthing and stuff. This is what that will actually save you from any harm. Okay, this is your first line of defense. Okay, this is what you'll be using. Okay, high rec. Okay, how you remember it? IRAC. HI is hazard identification, RA is risk assessment, and RC is risk control. Okay, so you identify the hazard. Okay, when you work any installation or premises that you go into, usually you will look around what is there. First, what you will look at. You look at escape route, the exit route, correct? That's you always identify. Okay. Next is you will assess. Okay. How you assess? Is it easier for me to run? Is it safe for me to run? Okay. Is it safe for me to walk? Is it? That's what you will assess. Okay. Then control. How you control it? Okay. Is it your safety boots? Okay, that's one of your control. Okay, is it should I run during an emergency with torchlight? Okay, simple things like that. Okay, that is risk control. Okay, why I say this is really important and learning all the technical part of it. Why this is important? Because when you do risk assessment, you have to go through all that JHA, job hazard assessment, all the paperwork that you have to go through, which will actually stop you from taking that job in. Okay, meaning that by identifying, assessing, and then you think about a control. Okay, you can even stop from the identification itself, hazard identification itself. Say, okay, I see this hazard here. Okay, it's not safe to work. It's a no-go to start work. Okay, you assess. Okay, you see the hazard. You assess. Okay, can you find a way to do? And then you find it's also risky. No go for the job. Okay, you already stopped. That's the first line of defense. Your paperwork, nothing else. Okay, see risk assessment here. What it says: risk assessment must be carried out and documented before the commencing of task. What it says: every workplace, the employer, self-employed person, and principal shall conduct a risk assessment in relation to the safety and health risk posed to any person who may be affected by his undertaking in the workplace. So this is one of the law which I already explained. Before anything else, you will do that identification, assessment, and the control. Okay. So we have this Workplace Health and Health Act. So this is the legislation you could refer to. Okay. Hazard identification. Okay, so like what I mentioned just now, when you enter any room, you will identify what are the hazards that you see. Is there a water leakage in there? Is there a slippery floor? Okay, the types of electrical hazard it might be exposed, things like that. Okay. Okay, another risk assessment that you have to undergo. Okay, this is very much basic that I'm talking here. There is more to it. Okay, your risk is actually severity times the likelihood. Okay, what is severity? What do you understand by severity? How severe is that condition? Okay, how severe? Okay, is it from negligible right up to catastrophic? So you have the levels 1 to 5. So you assess how safe or how unsafe is that area. So that's the severity. Likelihood means chances. Likelihood means chances. Chances of that accident happening. Okay. Okay. Let's say. Let's say a water leak. Okay, in your substation. Okay. What is the chances of it to for you to get electrocuted? Is it rare, almost certain, frequent, occasion? Okay, so it depends. How bad is the water leakage? Is it by drip? Is it by flow? We don't know. So you have to decide what level is it, the chances. Okay. So by doing this, then you'll know how high is the risk. So once they see the risk level is really, some that you have to stop, you really have to stop. There is no way for you to carry on the work. Okay.
So it's 1 to 25 5 and 25
Yeah. Yeah. So they will have.
Highest is 25 means.
Yes.
Lowest is 1 to 1.
Yeah. So this is just an indication for you, indication how dangerous to take up that job. Okay. Okay. This is something that I really like. This chart. Okay. This chart I really like this because if you see here, I only see the top and bottom. Okay. This is your first line of defense. You avoid the job as much as possible if it's unsafe for you. The last line of defense is your PPE. PPE, most people always concentrate on PPE. PPE is not your first line of defense. It's the last line of defense. Remember this. Your first line of defense is risk avoidance. So when you do that risk assessment, identification is what will actually help you from any harm. Okay? So the rest, engineering controls, blah blah blah, so all those things is secondary. First is avoidance. The last is PPE. Okay. But in certain cases, so you saw the first video earlier. Okay. He didn't avoid all the risk. He opened the door and then he switched on. And then he racked in a breaker that is already switched on. Okay. So all that he did not do. Because he didn't do this safety. Correct? You saw how the visor was melted. It's not this safety, but just imagine if only the energy was much higher than what your PPE could handle. This could have saved him, but he has to go through the last line of defense to save him. So it's like, okay. So just remember this. I like this chart actually. I like this photo. Okay, to remind everyone, it's like something that you could really remember. Just remember the first and the last. The rest comes in the secondary. Okay. Okay. So now you come to the PPE part. Okay. Your choice of PPE is also very important in the sense that if you go into 1 kV, below 1 kV LV switch loop, what PPE you have to wear, you know what's the voltage level, okay, you wear accordingly, okay, you don't have to wear everything, okay. So again, I'm adopting ABB's metrics, okay, for you to determine what actually you have to wear. So this is quite comprehensive. Okay, so this is what pretty comprehensive. Okay, so you have here. First of all, you look at which room are you going to get in. Okay, in a live room. Okay, whether you're going for a site visit, okay, or even just a minor to take some readings, okay. First you have to see what is the voltage level of the room, okay. You pick, let's say I'm going to 1 kV, okay, less than 1 kV, and sorry, more than 1 kV and more less than 7 kV. I think I prefer to go here. More than 480, less than 1 kV. Okay. So over here, you could see what are the PPE that is required. Okay. So one of the PPE that we have today, courtesy of reps. Sorry? UIT. Is we have here a glove. This is an insulated glove.
What's the wattage?
Class 0.
Class zero.
Class
Class
0
zero.
1000 volt.
1000 volt, which comes under here, right?
P, yeah.
P.
Correct?
Class.
Okay, so you have here, class 0. Correct? Does it match?
Yes.
Okay, so please have a look, go around, have a look. Okay, and then, okay, how many cal t-shirt you have to wear inside? Okay, because this is multi-layer. Okay, how many cal? 8 cal, and then plus another 8 cal. Then you have that 25 cal jacket and trousers. Okay, like this. Okay, so this is 8 cal. On top of this, you will be wearing this. If you are doing switching, okay, this is for switching.
Only for switching.
Mainly for switching. So if you are going for a visit, usually 8 cal. You are not going to touch anything. You're not going to touch anything. Okay.
So when you're in ABB, you wear all this.
I don't wear because I'm based in the factory. Okay, those who are going to site.
This should be more towards our guys who look inside. But I think you will wear a certain level of PPE, right, due to when you are doing testing.
Yes. The thing
The
that
tester will wear something.
yes, correct. The thing about sorry.
But this, I don't see anyone else implementing except for TNB. Yes, TNB they do implement this, but I don't see anyone else implement this.
ABB they have the
ABB, yes.
whole suit.
Okay.
It's mandatory for them to use. So each one of them, I don't know how many. Usually how many sets they have.
They will have two sets. One is the suit, another one is a coverall.
Okay. So they have. So we are not provided because it's quite expensive, really expensive.
Quite expensive.
Expensive. So those who are going to site, they have, every one of them have this. Okay. Another thing is that, do you see the leather glove? Have you ever wondered why you use leather and this together?
Because when you work on some sharp section, the rubber glove can get punctured.
Okay.
So what they do, they put another layer to protect it.
Okay.
That's one reason.
One of the reason, but not the main reason. One of the main reason is, can leather burn?
Leather.
No, leather doesn't burn. Not to say it doesn't burn, it burns, but after some time. Okay. I remember this many years ago. I seen people when they want to buy belt, leather belt. I seen them burning it to check whether that's a genuine leather or not. So at that time I didn't understand why. So why they wear leather outside? And this is to one is that leather doesn't burn very easily. It doesn't burn. So if it's a genuine leather, it doesn't burn. And then why is this second layer? Is because of water, as you say. Okay, if the leather part gets wet, okay, you still have this to protect you from electrocution. Okay, because this is rubber, right? So that's the reason you have leather and you have this together. Okay, so another point of selling point for you, leather.
That is very common. In welding work, so they get this welding rubber glove, right?
And people ask, now you know the reason, very good reason, leather doesn't burn. Okay. Okay, next is, I think this is would be a good metrics for you to refer to. Hence why I
Probably
adopted
what you mentioned is more suitable for switching, right?
Yes,
For switching.
most for switching. But everybody's it's a mandatory for them to wear 8 cal when we go for site visit. Not
8 cal.
doing no work, just site visit.
So also you have to know,
Yeah, definitely.
the company that we're dealing with, they do sell this, but they're not selling any of it in Malaysia.
But before you sell in Malaysia, you better check with the brand or what is widely accepted here in Malaysia.
As long as it's certified with a certificate, it should be acceptable.
Yes, normal companies, yes, but like ABB, they have their preference certain brand. I think they allow 2 brands. I can't remember what exactly the brand is.
No, because ABB is a corporate requirement, corporate approved, corporate auditor, so that's the reason they approve the 2 brands. But we can go to other brands.
So generally, if you have all the certification, then it's good.
And nowadays, a lot of PPE, they want DOS approval. If you have DOS approved, then it will be better for some market selling.
Oh, gosh, yeah.
Yeah, now PPE, right?
Because I
Safety
thought
helmet, safety shoe, certain few PPE that need to have DOS endorsement nowadays.
Okay. But what we normally, even like we are supplying to TND, like for example, yeah, I mean grounding equipment is not PPE.
Okay.
PPE, we don't really sell much PPE except for this kind of rubber glove.
Okay.
But all these are IC standards.
Yeah, maybe this one I don't think so because they have certain things lah. Maybe this one no.
And actually, this alone is very good enough for factory use because a lot of them don't only have this.
Yeah. I mean, one of the reasons we brought this is different compared to the normal class 0 insulated glove.
Okay,
One of it is very easy to work with this. Most glove is not easy to work with.
Yeah, correct.
The reason you can see the rough surface here.
Yeah.
This rough surface, it will enable you to take a small components from the table. The normal ordinary one is actually a flat. It's not a rough. So if you want to take any small component from the table or anywhere, you cannot take. This is rough, so you can take even a small nut, you can still pick up.
Yeah, I can see the difference from what I used to ABB. Okay, that's good. So you have a good storage.
Okay.
So you comes together as well.
Yeah, it comes the storage.
When I look at it, like it was a normal,
Household
household glove, but you look at it, but it can stand 1,000. I was wondering.
Just for your information, how much does it cost?
It's about 300 ringgit, around less than 500.
Okay.
Reasonable price. Reasonable price. I think last time we have bought more than this,
Yeah.
If class zero, if the class higher, the price will be higher.
Yeah.
This how much? They made in where?
This is made in France.
Okay. So, ear deafness. Okay. Then your safety shoe. Okay, your safety shoe is also leather type. Okay. And yeah, so the rest for you to refer to and use wisely based on the voltage. First thing is you see the voltage level, then you see what is the work that you'll be doing and use accordingly. Okay. Right. So moving on. Let's see. Okay. So use and care of PPE. your arc flash suit, when you go for cleaning, alright, you should not be using any bleach. Okay, so it will take away all the properties of a fire rating, correct? Right? Okay, so that's, you are not supposed to go for bleaching. I think not many dry cleaners know how to care for this sort of PPEs. Okay, so you have to tell them, okay, don't use this. Because for ABB, I know they have certain dry cleaning companies where they know what to do and how to wash it.
But it's very simple. You just have to
Just water.
water and salt. You are not allowed to use any detergent. I think just salt in the water and you dry it lah.
Yeah, so the cleaning is, as far as Malaysia's weather is concerned, you have to clean it very often. Okay? Alright. And then, okay, that glove, how you check if it's still in good condition or not? You have, I think, every 6 months or something, you have to change, correct? Or just inspect.
There is a tester, no? There's like a pneumatic tester where you can
Pump,
pump and you see whether it's holding the
Okay.
there is a tester.
Okay. Alright, so it's just your put
Pump
some
the
air
air.
pressure and then just hold it. Okay. Alright.
Because the most important, you should not have any puncture.
Okay, yeah, so that's the, okay. Alright, so moving on, we recap. Okay, so so we are coming almost to the end of the presentation and training. So what is the 3 methods of electricity are?
Shock.
Plus.
Plus. Okay, good. Next, what is the planning preparation method is used before commencing any electrical works? Remember?
Zero.
Remember? Planning and preparation. Correct. IREC. Okay? HI stand for?
Identification.
Identification. RA?
Assessment.
Good. RC?
Risk control.
Is good. Pass. Okay, the last one. What table is referred to for correct PPE choice?
ABB table.
The matrix, okay? Okay?
ABB
The electrical
matrix.
signal matrix. Okay? So, now with this, we've come to the end, and I would like to open this time for Q&A session. Any question? I think we had a lot of questions during our during the process. Okay, but if you have any other questions that you'd like to ask, I'm here. We have also other experts here, so we could answer your doubts. Okay, so you have any questions? No? Please feel free to ask. Michael?
No.
Any other question? Any questions? Simple one, whatever that you have doubts just now.
PPE. There's a lifetime for the PPE at the
The groups.
Yes, there is. I'm not so. Michael, do you have any idea? on
No,
this?
I'm not sure. I really need to check.
Okay.
Like helmets, all there's a lifeline.
Yeah.
I think there should be a lifeline for the clothings.
Yes, there is. Not so.
And also the groundings and everything, right? Does there any lifetime? I think it's a good question.
Yeah.
When we putting our training, but people might ask us to buy.
Yeah, yeah,
So we
definitely.
need to check on this also.
The lifespan of.
Yeah, especially all this, right? What is the lifespan will be? I mean, and then calibrations.
Yeah.
All these questions will come to us. How much? How long we need to do calibrations?
Yeah.
I think we should be doing calibration like these things. So
Yes, definitely.
Yeah,
It's
so
a,
that's
it's a yearly.
Yeah, that one.
calibration is
Yeah,
yearly.
that one need to put it in our this one.
Yeah.
slide. I mean, one of the point.
But now calibration they can go up to 2 years.
Okay,
Yeah.
yes.
Some equipment can go 2 years.
Which is not critical. For example, this is just to measure 240, it's 241 cats. And
Yeah.
so it doesn't have to so be precise.
One of the things that I experienced was, you know, the IR tester. Okay, IR tester, 1 kV or even 5 kV. So there was one customer who came. It's already calibrated. ABB, all their equipments are calibrated on time. So 1 kV. Okay, but when we inject, it was showing about 800 something, 900 something. Okay, then he asked, it's not injecting the correct amount as stated in the criteria. So what happens? What happens? Is it going to give me a correct value, correct resistance value?
This is no more calibration. Is probably a malfunction issue.
The thing is, it's been calibrated just for a month or 2.
But you can say breakdown.
But for IR, maybe the infrared meters,
Okay.
so they have the point of measurements. Maybe you are measuring the wrong
It's
one.
not for insulation resistance.
Insulation.
Insulation
Insulation
resistance.
resistance.
Insulation
No,
resistance.
not infrared
Yeah.
camera.
Insulation resistance. So that was the question for us. Which is, he was right, he was correct. We didn't, because you don't,
The right
it's not a
way.
variable. Okay, it's just 1 kV or 500 volt or 5 kV.
It's collectible
Yeah.
type.
So there's some voltage drop in it. Okay. So, but when you ask, is it safe? If your if your resistance reading is really high, it's way past what our criteria is, then it's okay. Not too bad. It's acceptable, I would say.
Acceptable.
It's acceptable. Because the criteria is 10,000 ohms, but your reading shows about 1 mega, so it's more than enough at 800 volts. Okay, so it all in your discretion, your understanding, and how you explain to customer. Let's say if it drops, okay, and your reading, I'm getting a very high reading, okay. So it should be okay, but then again, it's best to always keep all those tip-top condition. Okay, especially when you go to high-end customers, oil and gas. Okay, we're very particular about that. Okay, those things. Okay. So any other question? One more last question, then we can close.
Okay.
You okay, Bob? Okay. You have any doubts from the course here? Have you learned much? Have you picked up in this course? Even if you pick up one item, okay, one item that you have learned, still a success, I would say. Okay, because it's a learning process. Even if it's one, then I have done my job well. Okay. So like I think we picked up quite a number of points based on this. I think for beneficial for all of us. Even for me, I've learned something new. Okay, so if no, then you'll be like, okay. So I believe by this end you have already understood, because you answered your question, the 3 hazards, and then what you apply, risk assessment, okay, and then your safety metrics you answered all correctly. So it's a good thing. So thank you very much. Give a hand for yourself. Thank you, Bala. Thank you, Bala.
Thank you.
And Silva and Michael.
Thank you.
All right, hope
Thank you.
to see you again in the next training. And yeah, here we go.
Thank you
Contact
very
them.
much.
Okay.
Thank you a
All
lot.
right. Okay. Thank you.
Thank you, sir. Thank you for your time.
Okay. What time?
Thank you, sir. Thank you for your time.
Thank you.
Okay, thank you. Thank you, sir. Thank you.
I guess.